functions. Here we go, okay? Let me just remind you of a couple things about functions. A long time ago, we had a formula, I guess if you want to call it, that said x minus h plus k, okay? And so whatever was inside the group was the opposite, and whatever was outside was the same. So what we had talked about was whatever was inside the group moves left and right, and whatever was outside the group moved up and down, but inside was opposite of what we thought. So, for example, if it was negative h, it would move to the right, but if it was positive h, it would move to the left. But then the number outside of our grouping was, if it's a positive k, it moves up like you would think, and if it's a negative k, it would move down like you would think. Okay, so that's how you can actually do these in a quicker way if you remember those rules. So for example, this would be to the left 2 and up 1. Okay, but if you notice, this from the center does not go to the left, it actually goes to the right, so that's why it's not this one. This would go to the right 1 and down 2. It does not go to the right 1 and down 2, so that's why it's not that one. This one would go to the right 2 and up 2, and that's why it does go to the right 2, but it doesn't go up. This one goes to the right 2 and down 1, and that's how this is, right 2 and down 1. So that's why it would be this one. You could also use your calculator to make sure, or you could have used your calculator originally. But that was the shortcut in our shifting, in case you want to put that to memory, because I actually think that goes faster. All right, some other things about functions. Some people had some questions about this one, number 8. All right, it says, which could be a graph of? Well, remember, look carefully at it, and it says, let me make it a little bit smaller, that way we can see all of the graphs. All right, one more. All right, so it says y equals ax to the third plus bx squared plus cx plus d. Well, remember, when you're looking for the type of graph, all you have to look at is the exponent. So the exponent, the highest exponent, or the degree, is a 3. So that's how many directions it goes in. So this only goes in one direction. This only goes in 2 directions. And this one goes in 3. 1, 2, 3 directions. So that has the power of 3. And then this one would be 4. 1, 2, 3, 4. So that's why this one, you don't need numbers. You don't even have to put it into your calculator. The highest exponent is 3. That's the degree. 3 different directions. So that's the graph. Let's see. That would be the same thing like for this one. 1, 2, 3, 4 directions. So it should have an x to the 4th for the highest power. All right. What other questions do I remember? All right, this one, students had questions on, but I'm pretty sure it's just because it was hard to read. So here, just make sure you realize this is actually negative 0.5, which is negative 1/2, and 3.5, which is 3.5. So I know it's hard to see on your sheet. So when it says, apparently the function has turning points, here's one of the turning points, here's the other one. Well, this one is negative 1/2 because it's halfway through, and positive 1, 2, 3.5. And so that actually is this answer. Some people didn't see it just because they couldn't see the decimals, but that is negative 1/2 and positive 1/2. Just remember, okay, we also talked about increasing and decreasing, so let me zoom this out so that we can see all the answers. All right, remember, for increasing and decreasing, you want to, you go by the turning points. So since there's a turning point there, that means that breaks it into an interval. All right, and the x value is negative 1. All right, the point here would be -1, 0, but you only care about the x value, which is the -1. There's another turning point here, which breaks it into another interval. All right, and the x value of this point is +1. Okay, so it's -1 here, +1 there. And so it breaks it into 3 intervals. Remember, so the problem says, click and highlight each expression that represents increasing. All right, well, increasing means to go up. When you're reading from left to right, it goes up. So that's increasing. Okay, decreasing would actually be if it goes down from left to right. Okay, so when you look from here, which remember off to the left is from -infinity, off to the right is +infinity. All right, so when you look from here, -infinity, until the first break, the first interval, the end of the first interval, this is actually going up. It's actually rising, it's increasing. So this is one of our intervals. So from -infinity, and it stops going up at -1, -infinity to -1. Then if you look carefully, it is actually falling right here. So that would be a decreasing interval. So we do not include that one. But from here on the right side, it goes up again. So that is increasing again from 1 off to forever, off to the right. So that's from 1 to +infinity. So 1 to +infinity. So it is coming from -infinity and it is going off to +infinity, but there's a break between -1 and +1. So it's increasing in those two, but decreasing for that one. So since the question is just increasing, we circled those 2 intervals. All right, let's see what other questions I remember. All right, just remember domain and range. Domain is left and right, so can you pick all numbers to the left and all numbers to the right? That would be all reals. And this would be all reals, all numbers to the left and all numbers to the right. Range is all numbers up or all numbers down. The range would also be all reals in this case. Remember, if it's got a turning point and it only starts at one place and goes down, or starts at one place and goes over, that's when it would be one of our other types of domain and range, where there's a starting point and then it's that greater or that less. But this one is all reals. So, let's see. I think we may have talked about this one as well. Number 4 right here, where it's asking about end behavior. So remember, end behavior, it's not left to right. End behavior is, as it goes off to the left, what direction is the graph pointing? And as it goes off to the right, what direction is the graph pointing? So, so let's put this into the calculator. Let me start my calculator up again. All right, so here we have it. Let me put in y equals, clear out what we had, x to the 3rd minus 4x squared plus 4x. All right, so we did talk briefly about how you could find this by using the degree and whether it's positive or negative, but we talked more extensively about looking at the graph. So remember, when it comes to the graph, this is what it looks like, in case it's hard to see, okay? As it goes off to the left, what is it doing? That would be approaching -infinity. As it goes off to the right, what is it doing? So always remember that it's -infinity to the left, +infinity to the right, -infinity down, and +infinity up. So the question is, as x approaches infinity, so that's +infinity. So as we go right, what direction is that pointing? Is it pointing up or is it pointing down? Well, we can see that it's pointing up for forever, so up is +infinity, so it approaches infinity. All right, so positive and up, negative and down, or they could be switched. So usually it's always as x approaches, that's our left and right, so you just decide up or down. So that was how we dealt with infinity stuff. Let's see. All right, I think these are two good ones just to not forget about. Oops. There we go. And, oh, there we go. All right, just remember the power of something tells you how many total roots, but then the number of times it crosses are the real roots. So this is 1, 2, 3, 4 directions, so it's x to the 4th, which means it has a total of 4 roots. Okay, it has 4 roots all together. Then you decide, okay, well, how many are real, how many are imaginary? So now, how many times does it cross? Well, it crosses 1, 2, 3, 4 times. So there's 4 roots, and they happen to be 4 real roots. So 4 real roots, 4 different real roots. You don't have any imaginary because it's not up above. Okay, because you could have it above. Remember, that just means it doesn't come down low enough to cross. All right, this one, same idea. It's got 3 directions, so that's an x to the 3rd. So that is 3 roots. Okay, but if you notice, it only crosses 1, 2 times. So there are not imaginary roots in this case, there's a double root. And that double root is right here where it just touches it and then goes back off of that graph. So if it was imaginary, it wouldn't even touch it. So it touches it, but it doesn't cross it twice. So this stands for the double root, which is between 1 and 2. So remember, if it just hits it one time, it stands for that double root, which I know we saw in some equation stuff as well. All right, I think for the most part, everything else was not too hard. I may have had a question on this one right here. Remember composite functions? You put one inside of the other. So this is saying to put f. So put this inside of g. So you put f inside of the g. All right, so take this, and in place of the x, take that x out and put that in instead. So that just means, and actually, this is more how we would see it. All right, we have the g function, x minus 3. We take out the x, and we put in the f of x, which is x squared minus 2x. So it looks a little crowded, but that's really what you're doing. You're taking out the x, putting in the f function, so it's x squared minus 2x minus 3. So that's why it's this one. If you could, you would combine like terms, you know, put your x's together, distribute sometimes. This one is pretty easy, okay? Over here, remember inverse just means the opposite. So, since we're adding 2 here, you would just be subtracting 2. The long way to do it is you originally have y equals x plus 2. So the inverse is to switch x and y and solve for y again, and that's why it's the opposite, because when you solve for y, you do the opposite to get this stuff away. So it's x minus 2. So whether you do it the long way, where you put in, switch, and solve, or you just think plus 2, the opposite's minus 2, either one gets you that inverse. All right, asymptotes, we've talked about a few times this towards the end here again. So just remember, if you're looking, if it's being asked for vertical, look horizontal. Okay, so if it's asked for vertical, look horizontal. So that means that we take this x minus 4 and we equal it to 0. So if it's asked for vertical, look horizontal. That means x minus 4 equals 0, add 4 over, and x equals 4. All right, and then if it asks for horizontal, look vertically. And if we look vertically, we divide the x's, divide the highest x. So if it's x squared, you divide your x squareds. If it's x's, you divide your x's. If there's one missing, put in a 0, and it usually comes out as 0. But in this case, we've got x divided by x, which that's 1 divided by 1, so that's just 1. So that's y equals 1. So if the vertical is x equals, the horizontal is y equals. So this one would be dragged here, and that one we should drag there. So just remember, think opposites. If you're asked for vertical, look horizontally. If you're asked for horizontal, look vertically and divide those. Okay? And again, if you were given, because I do think you might see this, if you were given something like this, over x squared plus 2x plus 1, okay? If you were given something like this and you were trying to find it, since there is not an x squared to pair, then you think of it as a 0. And when you divide 0x squared, because there's not an x squared there, over a 1x squared, it would be a 0. So this, horizontal asymptote would be y is 0. So if the highest power is missing from either one, then you just put in a 0, and it normally will work out. If the 0 were in the denominator, it would be you wouldn't have an asymptote, because remember, you can't divide by 0. Just as a heads up, in case you were to see non-matching powers, that's what you do. Put in zeros for the missing, and then go from there. Okay. Don't forget that zeros, you know where to look on the calculator for that, but here, remember, zeros are opposite. So if the 0 is -4, the factor is +4. Okay? And remember, factors are the only thing where they're opposite, and it's a binomial. It includes the variable. Just so that you're good with your definitions. All right, the rest of them are pretty easy. Again, if you know the zeros, these are one of my favorite ones, but if you know the zeros, don't forget to switch their signs when it comes to finding their factors. So if this one is, I would write them down. The zeros are -2, -1, and 1. So that means their factors are the opposite. +2, so that's that one. +1, that's that one. -1, because that's that one. So I would write them down and not try and shift it in your head. Because if you try and shift it in your head, you may make an accidental mistake, even though you know what you're doing. All right, that looks like it's it. So hopefully that's enough questions. I think you guys are pretty squared away, except for those little details and making sure you could see all of the parts. So hopefully this answered your questions and you are ready to go. All right, good luck, guys.